later. Okay. Like I said, the notes for today are in the folder. We are working on analyzing polynomial graphs. And we are going to start by taking a look at a table of values here and just asking ourselves a couple questions. This is very similar to something that we've seen before in the last chapter when we were talking about quadratic equations, right? Being able to determine where my zeros are, where my solutions are. Later on, we'll start talking about roots, right? They all kind of mean the same thing. So let's kind of wrap our heads around that first as we relate it to polynomial functions. If I take a look at this equation here, so I have negative x to the fourth plus x cubed plus 3x squared plus 2x, right? I took those x values, I plugged it in, I get these y values here. And the first question I have for you is, what do we notice about this table? Are there any solutions that kind of pop out or stand out to us immediately? Is there any place where I can say that's definitely a solution because I might have a 0 in my f of x? What do we think? Are there any solutions to this equation? Remember
one solution?
What's that?
Is it one solution?
So where do you see that one solution right now? What x value?
Zero.
That x equals 0, right? So if you were to look, remember solutions, their f of x or their y values are 0, right? It's because it's along that x-axis. It's either touching it or crossing it. So we're thinking right now, maybe it's one solution because at x equals 0, I have a 0, right? So that should stand out to us. Something that we should be able to see right off the bat. At x equals 0, I have at least one solution, okay? But my follow-up question is that our only solution? Because what can we infer about what's going on between the values of 2 and 3 on my x-axis? What can you notice that's a difference in the y values between 2 and 3?
One positive, one negative.
One's positive, one's negative. So one's a positive y value, one's a negative y value, which means that one value, so if I were to plot this, one value at 2 is up here at 8. The other value at 3 is down here at negative 21. So at some point, to get from this point to this point, aren't I crossing the x-axis? And when I cross the x-axis, doesn't that imply that I have another solution, right? So you can't be so strict to just look for zeros, right? Although there's a point here at 0, 0, and my graph maybe looks something like that. It's not always going to be the case, right? Remember that when we did this before with quadratic equations, we looked at maybe where my y values went from positive to negative or from negative to positive. That also was a place that we could determine there were some solutions, all right? So what can we infer about the graph? Well, we could say it crosses the x-axis between x equals 2 and x equals 3. So there is a solution there. It's going to cross that x-axis if it goes from a positive to a negative in the y values or vice versa. So that's where I'm going to have a solution. Okay. Any questions about that? Between those points, so that next bullet point, where you go from a positive to a negative or from a negative to a positive, that's called a location principle. All right. So tonight on your homework or on the quiz on Friday, it'll say like find the zeros, find the location principles based off of this table or given this equation. So what you're going to do is create that table of values. And it's essentially where your graph crosses that x-axis, right? It goes from the positive to negative or from negative to positive. That's called your location principle. That's where you're going to have a solution. Okay. So you're going to hear those words kind of being thrown around. Make sure you're familiar with those terms and what it's asking you. All right. Let's do an example together now. Because tonight on your homework, it'll just give you an equation. We want to create a table of values, try and understand maybe where I have some of these zeros or what some of these solutions. So I'll kind of do the first one on my own and we'll walk through it. I have f of x is equal to x cubed plus 2x squared minus 4. All right. I'm going to take these x values and I'm going to plug them into my equation. That's what's going to give me my f of x or my y values. All right. So for you tonight, what you're going to do is take that equation, plug in some x values. You can do it by hand like I'm going to do right now. But I would suggest if you can use a calculator. I know Desmos kind of has a built-in calculator that you can use to make sure you definitely have the correct y value. So that's going to help us along the way, even for what we're talking about later on. Okay. So for example, if I take -3, I plug that in, that's going to give me -27 plus -3 squared is 9 times 2 is 18 minus 4. So when I plug in -3, I have -27 plus 18. That's going to give me -9 minus 4 gives me -13. All right. So I'd want to go through and fill in all of my y values based on plugging in these x values that are given to me. Okay. I would do this. I'm just going to show another one. I'm not going to do it for each one, but I would do this again, plug in -2. I have -2 cubed plus 2 times -2 squared minus 4. -2 cubed is going to give me -8. Again, use a calculator or any kind of app that's going to help you solve these. 2 times -2 squared is +4. 2 times 4 gives me 8 minus 4. Well, it's -8 plus 8. That's going to give me 0. 0 minus 4 gives me -4. Okay. Any questions so far just about that process of kind of just plugging in values and solving? Okay. You would continue this process, and this is going to be your first step, is to plug in those values, get your y's. You would get, if you plug in -1, you get -3, 0, you'd get -4, 1, you'd get -1, 2, you'd get 12, and 3, you would get 41. Okay. So now my question for you is to follow up, very similar to what we did in the first example. Do we have any solutions that stick out to us right away? Are there solutions that might be between two x values? What do we think? Do I have that location principle where I change from a negative to positive anywhere? And if so, between what x values does that occur?
Would you say what number, like the x value is, or what is in
Yeah, so you're going to
between?
say, like when you list your answers for anything that we're doing, it's always going to be the x values.
So x equals 1, right?
So not just x equals 1, but specifically between 1 and 2. Right? Because I'm going from a negative number to a positive. So all you need to do after this, especially for what we're doing right now with zeros and then what we're going to be doing later on, look at your y values. So I go from negative to negative, a little bit higher, negative, back lower, higher, and then I go to a positive number. So I'm just going to look at where I go from a negative to a positive. That's where my solution is, right? And I'm going to list the x values. So I'll say, just based off this table of values, I have one real solution between x equals 1 and x equals 2. Just looking to see where I go from a negative number to a positive number or from a positive to a negative. Okay? Any questions about that example? That's going to be one piece of your homework and one piece of a question on your quiz on Friday. Okay? Everybody good? So just plugging in values and then looking at the table in the Y column there, or Y row there. We're going to do another example. Hopefully this one is a little bit easier for us. Hopefully we start to kind of get the idea solidified. I have f of x is equal to x to the fourth plus 2x minus 1. Again, you would plug in this list of values, or create your own table of values. That's going to help you. I would suggest doing that tonight on your homework and on the quiz. But just for kind of the sake of time, when you plug in -3, you get 74. When you plug in -2, you get 11. -1, you get -2. When you plug in 0, you get -1. 1, you get 2. 2, you get 19. And 3, you get 86. Again, just as a very specific example, if I were to plug in 1, I have 1 to the fourth plus 2 times 1 minus 1. Well, that's 1 plus 2 minus 1. So it's 3 minus 1, which equals 2. That's how I get the 2. All right. Like I said, you could do it by hand, or I would suggest doing it by a calculator. The follow-up question is going to stay the same, though. If I'm looking at the table of values there, where are my solutions going to be? So I want to look to see, maybe, is there a change in y values from positive to negative, or from negative to positive? And then I'm going to list between which x values does that occur. So where are my solutions for this polynomial equation?
Between -2 and -1
Good.
and 0 and 1.
Awesome. So between x equals -2 and x equals -1, right? I go from positive to negative. So I'm crossing that x-axis, right? Let's think about that visually again, as we saw back on the first page, right? With that first example, it's where I'm crossing between those values. So my change in positive to negative allows me to say that it's between those values, and also between, as you said, x equals 0 and x equals 1, because then I go from a negative to a positive again. So I'm crossing back over that x-axis. Okay. Any questions about that example? Remember, those are where my real solutions are. Something that's unique about polynomial graphs, remember, when we did this with quadratics, we kind of only had to fill in half the table because we knew it was symmetric. Polynomial graphs are not always going to be symmetric. All right. So it is important that you plug in every x value to find what that y value is. So you can't just do half the work and kind of just fill in the blanks. Make sure you're taking all of those x values and plugging those in. Okay. And this is where I'm going to find my solutions to my polynomial equations. A lot of times it'll tell you, instead of saying like between, it'll just say like estimate the actual x value. You can write between this and this. I'm fine with that for your final answer. Okay. Any questions about finding the real zeros of a polynomial equation? Very similar to what we did before. Hopefully that was a little bit more of a refresher for us than anything new. Everybody good? Okay. The next thing we're going to look at is a little bit more of a new concept. However, it's very similar to what we just did. We're just kind of look at our y values in a different lens. All right. We're going to be talking about what's called the maximum and minimum points of a graph. All right. Specifically with polynomial equations, since that's what we're talking about in this chapter. You'll hear me refer to these as kind of like peaks and valleys, or, something very similar, something that we can equate to or relate to, with that kind of language. But the relative max and min, if I were to take a look at this, point A is my relative max, since there's no other nearby point that has a greater y value. Okay. So there might be values, as the graph continues on in each direction, that will be greater or lesser. But as I'm looking at it in this period, in this, between these X values, these are my relative max and mins. So the relative max, there's no greater point, whereas the relative min, right, visually, it's that valley there. There's no other point that has a lower Y value. Okay, so there's no other point that has a lesser Y value within that range there. Okay, so visually, that's what that looks like. Relative mins here, relative max is here. Another thing that these could get referred to, and we'll talk about this a little bit more tomorrow, is what's called a turning point. And what's going to help us we see it visually, but we'll talk about it more when we actually list our Y values in our table, very similar to what we just did. Notice that my minimum, I'm decreasing, I'm starting to decrease. I get to my minimum and then I start to increase, right? It starts to turn, it starts to change in the Y values. Similar with the max, I'm increasing until I get to that point, and then I start to decrease. So let's try and wrap our heads around that, because that's going to be helpful for us to be able to understand where my max and min are, just given a table of values or given a graph, whatever we need to kind of focus on. Okay? Everybody understand what a relative max and min are, just on kind of the surface level for right now? Any questions at all? Okay, like I said, we'll talk about this a little bit more tomorrow, but they're referred to as turning points. The biggest thing that we might want to make a note of, when the Y values get smaller before and after, or it's increasing before and after a certain point, or increasing and then decreasing after a certain point, that's my max, right? So I have a smaller value, I reach a peak, and then I have a value that's smaller after that. I'm going to look at that X value where I had the peak. Similarly, with the Y values, if it starts to get bigger, smaller, it reaches that lower number and then gets bigger again after, I'm going to look at that point where I had my minimum value, right? That's going to be my relative max versus the relative min, okay? We could also, like I said, talk about increasing and decreasing and how that's going to help us find our values for these maxes and mins as well, okay? So the first example, we can go through some of this together since we're also going to find the zeros again, but the relative max and min part I'll do on my own for the first example, and then we'll take a look at another one and then discuss the homework, okay? Kind of a game plan for the rest of the class period. So it says create a table of values for the following function, sketch the graph, determine the zeros and the relative max and min, okay? So our equation that we have here is x cubed minus 4x squared minus 2x plus 3. So I'm going to find my Y values the same way that we described that before. If I were to plug in -2, I have -2 cubed minus 4 times -2 squared minus 2 times -2 plus 3. Well, -2 cubed is -8. -2 squared is 4 times -4 is -16. -2 times -2 is +4, and then plus 3. What would be my Y value? So somebody help me simplify this from here. I did the first step for you. What would be my Y value after I plug in -2?
-17.
-17, good. -18 minus 16 is -24, plus a 7 gives me the -17. Let's do one more value. So if I plug in -1 cubed minus 4 times -1 squared minus 2 times -1 plus 3. Well, -1 cubed is going to give me -1. -1 squared is +1 times -4 is -4 plus 2 plus 3. What is my Y value when I plug in -1 into that original equation?
Zero.
0. I have -5 plus 5 gives me 0. Good. If you plug in 0, it's going to be 0 minus 0 minus 0 plus 3, so it's 3, right? You would continue this process along to find all the values You have 1, -2, 2, -9, 3, -12, 4, -5, and 5, 18. Okay. Well, part A is still the same as what we did earlier. So in part A, it's asking us, well, what are the zeros? So if I take a look at this table of values, similar to what we did before, where would you say the zeros are? Where are my solutions to this polynomial equation, or this polynomial function? One of them is pretty obvious, right? Where would my solutions be? Anybody have any ideas? Is there a 0 in my table for f of x? Do I change from
0,
negative
3.
to positive? What's that?
0, 3.
So my 0 has to be in the y value. So it's not going to be 0, 3.
-1, 0.
-1, 0, right? So I have one solutions at x equals -1. There's no other zeros in my f of x, right? So I want to look to see maybe where I change from positive to negative or from negative to positive. Does that occur anywhere? If so, between what values?
Between -2 and -1.
So that's okay. Between -2 and -1, I go from a negative to exactly 0. So I'm not really crossing the x-axis. Good. 0 and 1 and 4 and 5, right? Is that what you said? Good. So between x equals 0 and x equals 1, notice I go from +3 to -2. So from a positive to a negative. And then also between x equals 4 and x equals 5, because I go from a negative to a positive. Right? Those are where my solutions are. One thing that's also interesting to kind of take a look at, notice I have 3 zeros, and my exponent of my polynomial equation is x to the third. A lot of times that highest exponent will tell you how many real zeros there are. Sometimes it's not always the case. And you'll talk about that a little bit more moving forward, and either in the end of this class or another math class, but it should tell you how many zeros you have, okay? So we see an example of that. Now, part B says to find the relative max and min. So this is the first time we're doing this. What I'm going to do is I can do one of two things. I can take a look at my y values, right? And I want to see maybe where I start to increase and decrease, or I take a look at a middle value and see am I or my y values greater on either side, lesser on either side, and kind of just take an idea of whether that's going to be my max or min just by looking at the f of x row there. So notice I have -17. Then I go to 0, so I'm increasing. Then I go to 3, so I keep increasing. And then I start to decrease, right? If I take a look at that 0, 3, notice that my y values are smaller on either side, right? And that note above, if my y value starts to get smaller before and after a certain point, that's what's going to give me my relative max at that x value. So in part B, I have a relative max at x is equal to 0, right? Because I was increasing on either side of 0 and then decreasing, and my y values were smaller on either side of the y value at x equals 0. Let's take a look at what this looks like visually. At -2, I'm down here somewhere at -17. Then I go -1, 0, 0, 3, and then 1, -2. So visually, if I were to plot these points, This is what I'm working with so far. I start to increase, and then I start to decrease. Or my y values were smaller on either side of that point right there. So at x equals 0, that's where I have my relative max. Okay. I'll keep looking across my table of y values. Before we do that, though, does anybody have any questions about how I found that relative max? So whether looking at it graphically or looking at the table. Everybody good? Okay. I'll keep looking at my values. Now I go from -2 to -9. So I'm decreasing to -12, decreasing. And then I start to increase. So at 3, -12, right? Look, I have higher y values on either side. Let's go back to that note. If my y values are greater or bigger on either side of a point, well, that's going to be my relative min, wherever that x value is. So my answer in part B here, I also have a relative minimum value at x is equal to 3. You're always going to have x values for your answers, right? For solutions or your max and min, it's always going to be an x value. Let's see if this looks like visually. At 2, I'm at -9. 3, I'm at -12, so somewhere around here. And then 4, I go back up to -5. So my graph starts to decrease till I get to this point, and then I start to increase again. This point right here is my relative minimum value. Okay. I got that from looking at increase and decreasing. I look at the values on either side of this x, and I can also graph it. So I would suggest sketching a graph a lot of times for your problems on a homework or test or quiz to be able to kind of help you recognize what's going on here in each problem. Okay. Any questions about that first example, whether it was finding the zeros or finding the relative max and min? We are going to do another example in just a second. But does anybody have any questions, comments, or concerns about that first one there? Okay. Do the next example. Again, kind of just for the sake of time, we'll take that original function. So I have f of x equals -2x cubed minus x squared plus 2x plus 1. You're going to have to choose values to plug in. So I give you a list of values here. But like I said, we should know by now how to get the y values, right? We're just plugging in the x's, simplifying, doing that pencil and paper or using a calculator. When you plug in -3 into this equation, you get 40. -2, you get 9. -1, you get 0. 0, you get 1. 1, you get 0. 2, you get -15. And 3, you get -56. Okay. There's an extra column there. Just don't worry about that for now. Again, you would get those by plugging in the x's into the original equation and simplifying. Still have the same questions though. So given that table of values, right, which you would create on your own, you want to then determine where the zeros are and where the relative max and min values are. Okay. So part A, if I'm looking at the y values in that table, are there any that stick out as solutions for me? Where are my solutions to this polynomial function going to be?
-1, +1.
-1 and +1, right? I have 0 as a value. We've seen before that's not always the case. Sometimes we have to kind of estimate, and that's what it'll ask you to do between what values, determine based off of, if it was going from a positive to a negative. But here we actually are given those values, right? We're given 2 zeros. So I'll say my solutions are at x equals -1, and x equals +1, because they both have zeros in for the f of x or the y, whatever's easiest for you to kind of understand. Does anybody have any questions about that? Now let's move on to part B. Where are my relative maximum and relative minimum values? I want to be able to look at this table and kind of determine where those values are. So as I go across here, I go from 40 to 9 to 0. I'm starting to decrease. Where do we think our max and min values are? Anybody have any ideas?
0 and 1.
Okay,
On
so
the y.
what's that?
On the y, 0 and 1, which would be x equals -1 and 0.
Good. Nice job. Okay. So yeah, so make sure when we're naming, like I said, when we're naming relative max and relative min, we're naming it based off of the x values. But you're right. So it's at x equals -1 and x equals 0. How are you able to kind of determine that? If you can, I know it's kind of maybe tough to explain in words, but what do you think?
Because at x equals -1, the y value before it is bigger and the y value next to it. Wait, other way around, right?
No, you're right. You're right. So it's the relative minimum because of that, right?
Yeah, relative minimum because of that. And then at x equals 0, both sides are smaller than that number as well.
Good. Right. So that's a greater value than the two, the one before and the one after. So that's why I have a relative max at x equals 0. Nice. So we can think of it that way, right? That's one of the ways that I've given you to kind of describe where the max and min are. You can think about it also as I'm decreasing and then I start to increase again. So if I'm decreasing and start to increase, that's my minimum, right? At x equals -1. Then I go from 0 to 1 to 0. That's my maximum. Let's look at this on our graph. If I'm at -3, I'm up here at 40. Obviously, we don't have the 0.40. You can scale your graph if you want. I'm just going to throw it up there for now, just for the sake of being able to see what this graph looks like. -2, 9, -1, 0, 0, 1. So if I take a look at that first point, right, I'm decreasing until I get to here. Then I start to increase. So my minimum value is at x equals -1. Then I go from that point there to 1, 0. So I start to increase and then immediately decrease. This point here is that max, right? And you'll hear me say peak and valley. You can just look at that, once you get to the top of that graph and then the very bottom and then start to increase and decrease. That's where your max and mins are, okay? But we've shown it visually. We've shown it in a table. Whatever way is easiest for you to kind of grasp and rationalize this idea, make sure that you show it in that way. For now, do both, right? Create your table of values. If you need to sketch your graph, do that as well, whatever's easiest, okay? On your homework tonight, make sure you show both though, okay? Any questions about that example? Anything that we covered today, whether it was zeros, relative max, or relative min? Okay. Let's take a look at the folder for today. So Monday 3/15. Your homework for tonight is on page 334, numbers 15 through 21 odd. So let's take a look at that. Remember, the book pages are in the folder for you. So in each of these, you can draw a sketch of the graph. Part A, I'm not going to be too strict with, but I want you to find the zeros like we just did and find the relative max and min using your table of values for each polynomial function there in numbers 15, 17, 19, and 21. So you're going to plug in values, set up your own table, find where the zeros are, find where the max and min are based off of everything that we did today in class. Okay. Any questions about the assignment for tonight?